our last unit.
Yes.
And it's only a week long. Our test is next Tuesday. Yeah. Yeah. It's only about motion. And really, ladies and gentlemen, you know all the calculus that we're going to talk about today. The only new things will be what we use the calculus for. Okay? Those of you who have had physics, a lot of this will be very familiar. Let's just back up a little bit and wait, okay? Yes. That's okay. If you have not had physics, you are not behind.
Yeah, I took AP US history last year was.
Yeah, it will.
What if I have to work tomorrow?
Okay.
Wait,
so
the calculus is just two people and they go into the middle of Baxter Arena and we just all sit around. Because I was just like, because then some people see their backs.
I don't know how it's gonna work. This is the first year it's in Baxter Arena. Obviously, it used to be in the theater. Okay, so we're going to talk about motion, and we're talking about linear motion. So we have a particle moving along a line, back and forth, left to right, right, left, however it is.
Oh. Shut up.
Okay, anyway, so we're moving left and right. Instead of y and x, our variables are going to be s and t. So we're going to have an s-axis. That is going to denote where our particle is. We have our t-axis. That is going to denote when our particle is where it is. So we have time versus position.
Wait, why is S position? Shouldn't P position?
I don't. So S is position, it may not make sense, and it could be for some Latin word that means pace. Okay, so if we had a position time graph, okay, this is pretty lame. But if we are at position 1, so what this coordinate means is that 1 second we are 1 unit to the right of the origin. And origin, when I say origin, that's like the origin of what we're moving from. Okay, not the 0, 0 origin, but the position 0. Okay, here when time is 2, we are at the origin. We are at position 0. Okay, what does it mean if we have a position of -1? We're to the left 1. Okay, simple enough. Okay, let's talk about some calculus. So S of t is going to be your position. Your position function. Okay. We're going to talk today about graphical analysis and analytical. You are right there. Welcome to class. I know.
Still cardio.
Okay. Instantaneous velocity. Okay. With your neighbors, please define velocity for me.
No, that's value instead of value. No direction of magnitude.
Magnitude of speed in the direction of time and rate.
Okay, part 4, velocity.
Power 4. Yes. If you want to.
Distance over time with the direction.
Distance over time with a direction. Okay, so speed doesn't have a direction, velocity does, right? Okay, distance over time. Does that sound familiar?
Yes.
Okay, so when we talk about velocity, we're talking about a rate of change, a rate of distance over time change. So, rate of change, instantaneous rate of change, we are talking about a derivative. Okay, so when we take the derivative of our position, we get ourselves velocity. You are right. Okay, so S of t is going to be our position. When we take its derivative, we get velocity. Okay, so position, we're measuring like our distance, right? Our distance from 0 with direction, okay, left or right from 0. When we take the derivative with respect to time, we're looking at distance over time, so that is a rate. We have velocity. Okay, speed. How do we look at velocity and figure out what its speed is?
Just take away the direction.
Okay. So I'll write it as the absolute value. If it's positive, it stays positive. If it's negative, make it positive, right? Speed is not going to be something that I ask about a lot, but it's something you still need to consider. Velocity is going to be more important in this unit, okay, and especially with its relationship to position. Okay, right there. Okay, let's talk about our direction. So velocity, you have told me, has direction, positive or negative, okay? So let's go back to what we're talking about. We're talking about linear motion. Motion as we move left to right from a particular point of origin. Okay? So what does it mean if we have positive velocity?
Y is greater than
Y is greater than 0.
So we are moving
Right.
right. Okay? If we have up and down motion, we're moving up, but we're talking about left to right. Okay? Which means if we have negative velocity, we are moving
Wait, what?
so if we're moving left to right, negative
Down.
velocity, that negative is giving us the direction of we're moving left at that rate. Positive directions mean we're moving right at that rate.
Of the velocity, not the position. As in, when you have, say like that, that's, never mind.
We're going to go through two graphs, okay? We're going to look at a position graph, and then we're going to look at a velocity graph. Okay? Later on, we'll get to all the analytical blah, blah, blah. Okay, but we're going to look at graphs. Okay, remember, you know all the calculus. Okay? So let's look at this graph. Here is my position, t cubed minus 6t squared. That is our position. And this is what the graph looks like. Okay? So we are going to go through and look at this graph compared to the velocity, compared to the speed, and we're going to talk about different things. So first of all,
X to the third, or
yes. Sorry, I kind of threw over it, didn't I? Okay. What do these coordinates mean right here about the position?
position 0.
Okay, we have position 0 at t equals 0 and t equals 6. Also, notice we're always going to start at time equals 0. We're not going to have any negative time. Okay, so we don't even have to worry about this portion of the graph. Okay, all right. So, right here at time is 2, are we to the right or to the left of the origin? We are to the left because we have a negative position. All right. Over here, we are to the right because we have a positive position. Now, if I ask you when is it moving to the left, what would you tell me, Aaron?
0 to 6. No.
Do you disagree or agree with Aaron?
I disagree.
Okay, Aaron disagrees with himself. I'll give you a chance.
Let's go from 0 to 4.
0 to 4? He asked us a question. Somebody answer it.
0 to 4.
Okay, Zach Buzzard, you answered it. Explain to everybody why it's 0 to 4.
Because the slope is a negative slope from 0 to 4, which means the velocity is negative. Which means we're
Okay, so we're decreasing, which means our velocity is going to be negative, which means we are moving left. Okay, which means, Emma, when are we moving to the right? After 4.
Yeah.
I figured she just focused it all on one part.
It's not 8.
4 to wherever it's not.
What?
No, I did not say it.
That is the worst life ever. I don't want to say what you're thinking.
Doesn't look like I'm on.
You're like, I didn't say your name.
Okay, so now I want to talk about the velocity. Brady, what would the velocity equation be?
Or I guess that's the position. Which find the derivative.
Mm-hmm.
So it would be 1/3 or 1/4 t to the 4th minus 2t to the 3rd. Or no. We're finding the we're finding the derivative. 3t squared minus 12.
3t squared minus 12t. Agree or disagree? Okay, here's our velocity. Okay. Now I'm going to ask you what these coordinates mean. Jimmy? Speed of 0. Carter, do you agree?
I'd say velocity.
Okay. Both are correct because speed and velocity are related. But since we're talking about a velocity graph, it may be in our best interest to describe it as velocity is 0. Okay? But that's where our velocity graph is hitting the axis, and so our velocity is 0. What happens when a particle has a velocity of 0?
There's no
Stop
change in
moving.
position.
Okay. It is stopped at that particular time, right? More often than not, we're probably going to change direction, right? If you think about me moving right, and then I move left. Okay, when I change directions, I have to
Stop.
You have to run off. Run off.
No. So, so at t equals 0 and t equals 4, our particle is at rest, is what you're going to see it described as more times than not. Okay. Allie, what did you say? Okay, and tell me why. Okay, so from t is 0 to 4, we are moving left because our velocity is negative. Okay. John, when are we moving to the right? Why? because our velocity is positive. Okay? It's just like reading derivative graphs, right? You know the calculus, we're applying it to a new thing. Slow down, slow down. Okay.
So we have to write it like, we can write it like.
You know, I don't care, but, don't make me goofy. That would be very embarrassing if I had to move you in the fourth quarter of your senior year. You gotta keep your hands to yourself. I don't care how you write it, you're probably gonna see it written like this more, and I'll probably write it like this, just so we remember that t is our variable of c. Okay, but I'll accept that. Okay, now let's talk about speed. What is speed? What does speed do?
Velocity without direction.
Okay, so it's gonna take the absolute value of this, so anything that's negative becomes positive. Anything that's negative becomes positive. That's our speed. So our speed, if you look at it, is increasing, decreasing, increasing. Right? We're going to look at why that is here in a little bit.
You just keep going back and forth, that kind
Yes.
Go back quick. Based on this graph, I think just by looking at it, would it also be like slowing down and then turning? Because when you think about it, like if you take the second derivative, it would show in line, right?
Well, what this is showing is that it's, okay, so this graph is showing speeding up from 0 to 2, slowing down from 2 to 4, speeding up. So increasing, decreasing, increasing in speed. You see what I'm saying? So compared to here, increasing, decreasing, increasing. We're going to look at acceleration here next. And maybe that will help bring everything together.
Yeah.
Do you think so?
Yeah.
Okay. Do you have a question you want to ask right now? Okay. So let's talk about that acceleration word. 15 seconds. Define acceleration in your pod.
Velocity over time. Not necessarily getting the gas pedal to.
Okay. 2. Acceleration. Change in speed over time. Let me repeat that. Change in speed over time. Tristan, let's get some calculus thrown in here. Change in speed over time. How can you relate that to calculus?
Rate.
It is a rate. And what's another word for rate of change?
Related rate.
It's a derivative.
A derivative. Okay, so Tristan, it's a derivative of what?
Speed. Velocity.
Yes. Okay. Well, we're gonna say velocity because we don't want to try to take the absolute or the derivative of an absolute value. Okay. Acceleration. We are measuring the rate of change of velocity. Some of you are going to say, okay, when's the particle speeding up or slowing down? Positive and negative acceleration is not measuring that, but acceleration does help us figure out when we are speeding up and slowing down, right?
Is there a special letter for acceleration?
There is. Okay.
No, it's probably not.
So S is position. We're going to add to our little chart here. S prime is velocity. So our acceleration is the second derivative of position, or you can think of it as the first derivative of velocity, and we call that A of t.
Oh, so it's like a secondary graph where it goes with the rates. That's not so high as you
So this is kind of a nice way to end the year because we're going to talk about, We're going to talk about derivatives. We'll eventually talk about anti-derivatives. We're going to talk about reading graphs, points. Talk about it all. Okay? Now, just because I step on the gas, okay, I'll wait for you. I'll wait for you. Okay. If you're driving your car, yes, when you step on the gas, you are accelerating, right? When you step on the gas, you accelerate. Yes. Okay. Now, you are moving in one direction when you drive your car. Let's define, okay, if we're moving left and right, and we're accelerating, let's define when we are actually speeding up and slowing down, okay? Concave up doesn't mean we are speeding up. Concave down doesn't mean we're slowing down, okay? Acceleration, that is positive, and velocity, that's positive. So if we are moving to the right and we are accelerating to the right, what is that going to mean about our speed? Okay, we're speeding up. Now what about if we are moving to the left and we are accelerating to the left? You're speeding up. If your velocity and acceleration are going in the same direction, whether it's positive or negative, you're speeding up. Okay? So if your velocity and acceleration are both positive, or if your velocity and acceleration are both negative, you're speeding up. However, if you are moving left and accelerating right, it's called braking.
Yeah, is it brake shifting down?
Okay, so let's think about it. When you brake, right, you're slowing down because you're trying to stop your car, so you're accelerating in the negative direction, but you're still going forward. Okay. So when velocity and acceleration have different sign values, as in positive, negative, then you're slowing down. Yes.
How do you know if it's a constant speed?
If it is a constant speed, then your acceleration would be 0. Okay? So, let's go back to our original equation. What was, our position was t cubed, what?
6. Yes.
Okay? And so then Brady told us that our velocity was 3t squared minus 12t.
Yeah, prime. Yeah, not prime.
That's not prime.
It's good. Thank you. Thank you. Thank you. Okay. Say that again, Jimmy. 6t minus 12. Okay. So first I want to look at our original graph. This is our position versus time graph. When are we concave down?
Never.
Yeah, 0 to 3.
Oh, you are, aren't you?
We'll call it 2. Okay? From 0 to 2, we're concave down, but then 2 on, we're concave up, right? So this means our acceleration is negative from 0 to 2, but positive from 2 to 7. Okay? If we look at the acceleration versus time graph, okay, we see that here from 0 to 2 we have negative acceleration, and from 2 to 7 we have positive acceleration. Okay? But remember, that doesn't necessarily mean that we're speeding up and slowing down. Okay? The 0 to 2, 2 to 7. Okay? If we make a sign chart here, okay, we kind of start at 0. At 2, we go from negative to positive acceleration, right? And our velocity, when were we moving to the left? 0 to 4 we were? And to the right was 4 on? Okay. So from 0 to 2, we are speeding up because acceleration and velocity have the same sign. But from 2 to 4, acceleration's positive, but velocity's negative, so we're slowing down. Then after 4, we're the same sign again, we're speeding up. Okay. Which, isn't that what we decided here? Speeding up, slowing down, speeding up? Essentially. What? Did you have a legitimate question or anything?
We're just conversing about the subject.
Okay.
So, to find acceleration, you just like look at the cabin.
Yeah. We'll look at the second derivative. Yeah, so graphically you would look at the concavity. Analytically we'll look at the second derivative. Okay? Alright. This is what you guys feel more comfortable with. Let's do this analytically now. So write down this equation. Okay. Carter, what would you say our initial position is? Yes. Okay. We are 3 to the right of the origin when we begin. Okay. So let's analyze this. Okay. Carly, what is our velocity function? Yep, you want to take it for me?
6t squared minus 42t plus 60.
Awesome. Okay. Now, if I want to know when this is moving to the right and when this is moving to the left, what do we need to know about it? Okay, so we know that our particle is going to change directions when the velocity goes to 0. So if we know when the velocity goes to 0, we can figure out when it is positive, when it is negative velocity.
What if it's one of those cases where it changes from positive to positive? Then it's just that
Then it's moving right, it stops, it's moving right again. Okay, and then that's something that we would have to notate. Okay. So we're going to set it equal to 0. What do you suggest we do with the right side? Okay. You can divide by 6, factor out of 6. Yeah. So you can divide off the 6, is that what you're saying? Yes. So, what is this factor to? T minus 5, T minus 2. Okay. So, T equals 5 and T equals 2. So those are the critical points of our position, because that's where our velocity is 0. Okay. So our particle is at rest when T equals, I don't know where R came from, 2 and 5. Okay. So I'm going to make a chart here. I'm going to go ahead and put a 0 so we remember that we don't have to do anything to the left of 0. Okay. So we have critical points of 2 and 5. Do not go back up to this and plug values in. That's going to take more brain power than you need to expend. Let's go back to one of these, I would suggest maybe. Okay. If we plug in something to the left of 2, Between 2 and 3, if we plug in like 3, excuse me, 2 and 5, if we plug in like 3, it would make that negative. And after 5? Okay, so our particle is at rest at 2 and 5. Our particle is moving left when t is between 0 and 5. And we are moving right from 0 to 2 and from after 5, essentially. Now, since we have an initial velocity that's positive, you can include 0. I'm not going to get picky about it. If you don't include 0, it's fine. But we are beginning with velocity. Okay.
Would it be like, if you wrote it the other way, would you say like 5 to infinity?
Yeah. Okay. Let's keep going. Let's talk about acceleration. Okay. John, what's our acceleration function?
12t minus 4.
Excellent. And what do we need to do with that in order to figure out where we are positive and negative acceleration? It's equal to 0.
It was like
Or just solve
Okay, so to the left of 3.5, do we have positive or negative acceleration? To the right of 3.5, do we have positive or negative acceleration? Positive. Okay, so from 0 to 3.5, we have negative acceleration. From 3.5 on, we have positive acceleration. So I'm just going to write that here. So we have positive acceleration. You will not be asked to describe acceleration very often. What am I going to ask you to describe more often?
velocity.
Speeding up and slowing down. I'm going to ask you to describe velocity.
Once you start to do acceleration,
Yeah, well, for speeding up and
you
slowing
just
down.
don't have to
Yes.
write that.
Right. So you're not going to actually have to write this very often. What I'm more concerned about is where this is speeding up. Okay, so let's look at this. Where do we have the same sign? So at between 2 and 5, we have negative acceleration. And between 0 and 3.5, we have negative velocity. So where do those two overlap?
2 to 3.5.
2 to 3.5. Okay. From 0 to 2, we have positive velocity. From 5 to infinity, we have positive velocity. Where does that overlap with our positive acceleration? 5 on. Slowing down.
Is it, if it's 5 on, wouldn't it be greater than or equal to? Is there 5 not?
We wouldn't include 5 because that's where velocity is 0. Okay. Slowing down. 0 to 2. And 3.5 to 5. You can include 0, you don't have to, I'll take it either way. It's fun stuff, right?
Good time.
Okay, so this is what I'm gonna do. You are going to earn your homework. I need you to answer these 4 questions about this problem, and then I will check them and hand you your worksheet. Next Friday, I need this. I need you to get this signed and filled out by this Friday. I won't fill it out. When you hand it to me, I'll sign it.
We're not gonna get back into like that.
Can I just drive myself if I have early release? And I really don't want to come back to school.
Probably not, because we'd have too many people doing that. You're not going to have anywhere to park.